Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 20. Question number 20 is, consider the set of polynomials xt is equal to a0 plus a1t up to an minus 1 t to the power n minus 1 in t of degrees less than n such that x of 0 is equal to 0 and x of 1 is equal to 1. Then we need to find out whether the set of polynomials constitute a vector space of certain dimension or not. So let's get started. So here this question comes from the section mathematical physics, and the concept involved here is linear vector space. So first of all, what is a vector space? Now, by definition, a vector space is formed by a collection of vectors which must satisfy certain conditions. Now the conditions are basically, there are mainly two conditions. First condition is the condition of addition. Now what is the condition of addition? So suppose you have px is one set of vector and qx is another set of vector, where px and qx belongs to a set V, which is a set of vector space. Okay, so if you have two set of vectors px and qx, then the addition, according to the addition condition, the sum of px plus qx should also produce a third set of vectors which also belongs to V. So this is the first condition. Second condition is scalar multiplication. So suppose you have px, which is one set of vector which belongs to V, and k is a scalar element which belongs to S. Here S is your set of scalar. So according to the condition of scalar multiplication, in order to satisfy the condition, there should be a vector kpx which should produce a new set of vector which also belongs to V. So for any set of vector or polynomial to form a vector space, they must satisfy these two conditions. If one of them is not satisfied, then it will not form. So here we will test our given polynomial with both these conditions. If one of them does not satisfy, then it will not form a set. If both of them are satisfied, then it will form a linear vector space. Then after that, we have to decide which dimension it forms. So let's get started now. So here our given set of polynomial is xt is equal to a0 plus a1t plus up to an minus 1 t to the power n minus 1. Now here the conditions are given that x of 0 is equal to 0 and x of 1 is equal to 1. So first what we have to do is, we here don't know the value of the constant. So first thing we'll do is, we'll put these conditions on this polynomial and find out what is the equation we are getting. Basically the equation we get is regarding the coefficients of this polynomial. So here first condition if we put, that is x of 0 is equal to 0, that means when t goes to 0, xt also goes to 0. So let's put that condition. This will be 0 is equal to a0 plus 0 up to plus 0. All the terms are 0 except a0, since it has no t term. So this equation ultimately gives a0 is equal to 0. So first condition gives you this equation. Second condition is when t equal to 1, xt also is equal to 1. So if we put the second condition, here 1 is equal to a0 plus a1 up to an minus 1. Now in the first condition we have already got a0 is equal to 0. So if you put that also in this equation, ultimately you will get a1 plus a2 up to an minus 1 is equal to 1. Now here to find, now our purpose is to check whether this xt forms a linear a vector space or not. So to find whether this xt forms a vector space or not, first what we will do is, we will assume another, suppose there is another set of this vector, that is yt is equal to b0 plus b1t plus up to bn minus 1 t to the power n minus 1. And this also satisfy the same condition as xt, that is y0 is equal to 0 and y1 is equal to 1. So if under that condition this yt will also have the same equation as of xt, that is for xt we have got these two equations regarding the coefficients. So for yt also the coefficients satisfy the same condition. So that implies b0 is equal to 0 and b1 plus b2 up to bn minus 1 is equal to 1. Now the first condition is the condition of addition. Okay, so we'll check that. So first condition is addition condition. So according to that, the sum of the xt and yt should also be a part of the set. That means should also satisfy the same condition as satisfied by xt and yt. That implies suppose we take a third set of vector, that is zt is equal to xt plus yt. So as per the rule of the condition of addition, this zt also satisfies these conditions. That means z0 should be equal to 0 and z of 1 should be equal to 1. So we'll check that here. So now here we will put the values of xt and yt. So zt will be equal to, that is a0 plus a1t up to a n minus 1 t to the power n minus 1 plus b0 plus b1t up to bn minus 1 t to the power n minus 1. Now these two equations we will arrange it in terms of powers of t. So this equation will become, the zt will be equal to a0 plus b0 plus a1 plus b1t plus a2 plus b2 t square up to an minus 1 plus bn minus 1 t to the power n minus 1. So this is the final equation we have got. Now here we'll put the condition for t and check whether zt is satisfying those conditions or not. So first thing is we'll check if t is equal to 0. So if t equal to 0, here zt will be equal to a0 plus b0, because rest of the term will go to 0 because as we put t equal to 0 here. Now here we have already got previously that a0 is equal to 0 and b0 is also equal to 0. That means this also gives you the value 0. So ultimately we have got z0 is equal to 0. So the first condition is satisfied. First condition means I am talking about this condition. Okay, for the condition of vector space we are checking all now. This condition is satisfied for related to the polynomial. As x0 is equal to 0, y0 is equal to 0, so z0 we also have got is equal to 0. Now we have to check this condition. So if t equal to 1, so if t equal to 1, z of 1 will be equal to a1 plus b1 plus a2 plus b2 up to an minus 1 plus bn minus 1. Now you will rearrange it in terms of the coefficients of a and coefficients of b. So this will be equal to a1 plus a2 up to an minus 1 plus b1 plus b2 up to bn minus 1. Now here this a1 plus a2 up to an minus 1 we have already got, this is equal to 1, and b1 plus b2 up to bn n minus 1 we have already got as 1. So this will be equal to 1 plus 1 equal to 2. But the condition which it should satisfy what, z1 is should be equal to 1, but we have got z1 is equal to 2. That means z1 is not equal to 1. That means the second condition of the given polynomial is not satisfied here. So since it is not satisfying these conditions, so ultimately the first condition to create a vector space, that is the condition of addition, is not satisfied. So here we are already clear that the given set of polynomial, that is xt, will not form a vector space. Now let's check the options. So if you check the options, you can see that option D says it does not constitute a vector space. So that is the correct option for this question.